Hello, Professor. My name is Hardik Kumar, and this is my presentation for COMP3132 Machine Learning Assignment 3. In this assignment, we have two parts. In part A, we are doing image conversion using CNN neural network, and the second part, we are in the second part we are basically defining a CNN model and basically adding layers to it to see if it performs better. So in part A, we are first importing all these libraries which will help us to work with the images and detect the edges, etc. So we are importing the image, and most of this was the code that was already given to us. So in this code we are basically just showing the images that we downloaded. Next we are printing the shape of the image and comparing the values of color channel 0 and 1. 0 means next we are actually doing convolution with 2D kernels. So what convolution does is it learns pattern from images using layers to detect edges, shapes, and textures. It then classifies images into categories using dense layers. So we are doing that here. And first, we are doing standard convolution here. In this piece of code, we are basically making sure that the values less than 0 become 0 and the values more than 255 become 255, because an image can only contain pixel values between 0 and 255. Next, we are applying 2D kernel to an image. Next, we are detecting the lines. As you can see here. So we have our first questions here. Question 1a. Based on the kernels represented on the above image, create a kernel to detect 45-degree lines using convolution. Apply to the car's image and plot the result. So here we are applying where we wrote a kernel to detect 45-degree lines. And as you can see, it detected it successfully. In the next question, it says, based on the kernels represented in the above image, create a kernel to detect 135-degree lines using convolution. Apply to the card's image and plot the result. So here we're doing almost the same thing, and this time we are trying to show 135-degree angle edges. And as we can see, it's been successful in doing that. And the second question, we have to apply the following kernels to our images and plot the output. So this is our kernel A2A. So the first one is detecting the diagonals in the images, and 1 and -1 basically mean changes in intensity along the diagonal directions. And in 2B, we are doing almost the same thing. And the next one, what we're doing is we're using a Laplacian filter where the center pixel compares itself with all 8 neighboring pixels here, and it detects edges in all directions: horizontal, vertical, and triangle. This edge detector here is kind of more intense than the last one. And after that, we've come to part B. And in part B, we are first importing these libraries through which we can build our CNN on the Cipher 10 dataset, sorry. And we are first preparing our one hot encoded target values and then converting them from integers to floats and then normalizing them. Next, we are building our neural network model, and then we're using a custom callback class for logging. So what this does is it runs at the end of every epoch and logs the accuracy of our model after every 5 epochs. So in this snippet of code, we're finally training our model, and as you can see, the training accuracy is increasing as the model is getting more data. But we can also see that our validation accuracy decreases. This means that our data that our model was actually memorizing data instead of learning it, meaning overfitting. So here we are plotting the results. Next we have question 3 to 10. Question 3 says, did the network present signs of overfitting, and so then in which epoch? So as we can see, it started presenting uh, signs of overfitting after epoch 20, because the training accuracy keeps rising, but as I said, validation accuracy stops improving and then even drops a bit. So basically, this just means that the data, the our model didn't learn how to, like, it didn't learn, it just memorized stuff, which it's not supposed to do. So next question says, write down how many layers this model has and identify the types. Our model has five different layers, which are Convo 2D, Conv 2D, Max Pooling 2D, Flatten, Dense, which has 128 neurons, and one more dense layer with 10 neurons, which is our output layer. Next question says, briefly explain what is the purpose of each of those layers. So our Conv 2D layer, it extracts features from the input image using convolution filters. Our Max Pooling layer reduces the spatial dimensions of the feature maps to reduce computation and prevent overfitting. Next, flatten layer converts the 2D feature maps into a 1D array to feed into fully connected layers. Our 128 neuron dense layer is a fully connected layer that learns complex patterns from the patterned data. And our last layer, output layer, which has 10 neurons, produces the final output with 10 neurons representing the 10 classes in the classification task. Our next question is add one or more convolution layers to your model and run it again. Okay, so we've done that here. And we have trained it in the same batch size and same number of epochs. And here is our result. Next question says compare the results between original model made using Keras sequential versus bigger model with at least one extra layer added. So I've written down the answer here. It says the modified model with two extra con 2D layers performed better than the original model, and it achieved higher training accuracy and better validation accuracy, which means that it learned about more data instead of just memorizing it. The additional layers help the model capture more complex features, leading to improved performance and comparatively less overfitting. Next question says add a dropout layer to your model, run it and compare the result with the previous one. So we are adding a dropout layer to the model here, and here is the result. Next question says explain in your own words what is the purpose of a dropout layer and how it works. So a dropout layer basically helps the model avoid getting too focused on specific patterns in data, which can sometimes make it perform poorly on new data, and it randomly turns off some neurons during training so that the model learns to use different parts of the network. This makes the model better at handling new and unseen data. Alright, so that was it for my assignment 3 presentation. Thank you.